Have you ever been stuck on a coding problem that just doesn't make sense? It's frustrating, right? If that's you, then you're in the right place. Today, we're diving into a common issue in C++, the invalid comparator error. I totally get it. You write your code, run it, and then boom, an error pops up out of nowhere. You're not alone in this. Many developers face similar challenges, especially when dealing with sorting algorithms. Here's the specific situation we're looking at. One user recently asked, "Why am I getting an invalid comparator error in my C++ code?" They shared their code, which attempts to sort a vector of points based on their x coordinates. Sound familiar? Let's dig into this together. So, what could be causing this invalid comparator error? The issue often arises when the comparator function does not provide a consistent ordering for the elements being compared. Let's break it down step by step. And don't go anywhere. I've got a crucial tip at the end that will help you avoid this error in the future. To address the issue with the invalid comparator, the user needs to ensure that the comparison function is consistent. This means that if one comparison returns a certain result, the opposite comparison should return the opposite result. Next, the user should modify the compare_by_x function to handle the case when the two values are equal. This is crucial because the sort function relies on a strict weak ordering. Now the user can test the updated comparator by running the main function again. This should resolve the invalid comparator assertion. Finally, the user should review the sorting logic to ensure it meets their requirements. If the points need to be sorted by both x and y coordinates, additional logic may be necessary. Fun fact, did you know that sorting algorithms are one of the most studied topics in computer science? They can be as simple as bubble sort or as complex as quicksort, but they all rely on a good comparator. Now let's look at the answers provided by other users. A user points out that the comparator function must return true if the first argument is less than the second. They suggest rewriting the comparator to use a lambda function that directly compares the x values of the vector 2D objects. Here's the crucial tip I promised. Always ensure your comparator function can handle all possible comparisons, including equal values. This will save you from many headaches down the road. And there you have it. With this fix, your sorting should work perfectly now. Remember, a well-defined comparator is key to successful sorting. If you found this helpful, hit the subscribe button for more coding tips, and don't miss our next video on optimizing your C++ code.